Hello class, today we are going to discuss section 2.9, which is all about weighted averages. At the end of today's lesson, you will be able to solve mixture problems and you will be able to solve uniform motion problems. Mixture problems are problems where you are combining two or more pieces in different amounts to make a whole. So we're putting together different parts to try and make one whole number or one number to represent the group. Uniform motion problems are problems that are involving speed of an object, and for those you will need the equation D equals RT, which stands for distance is equal to rate times time. So distance is equal to rate times time. To give you kind of an idea of what we are looking at as a whole for the mixture problems, we're going to use the idea of slugging percentage in baseball. So you're taking all of the different hits that a particular batter gets, and you are trying to average them out to see how well they are hitting. So slugging is equal to 1 times your singles, because you get one base on a single, plus 2 times the doubles, plus 3 times the triples, plus 4 times the home run, divided by the total number of at-bats. So if our particular hitter gets 14 singles, 9 doubles, 4 triples, and 7 home runs in 8 plate appearances, what is their slugging percentage? So we're mixing together the different types of hits to get one whole slugging percentage. So we've got 14 singles plus 9 doubles plus 4 triples plus 7, home runs, divided by our total of 85 plate appearances. Simplifying that down, 14 for the singles plus 18 for the doubles, 12 for the triples, and 28 for the home runs, divided by our 85 plate appearances, gives us 72 over 85, or a slugging percentage of 0.85. So that's kind of the basic idea, is that we're combining things, but we are giving them different weights. That's why they call it a weighted average. The double gets more weight than the single. The triple gets more weight than the double, since we are multiplying by bigger numbers. So what we're looking at here is to make trail mix, a company mixes peanuts and raisins into the product. They sell the mix for $5 per pound. The peanuts cost $2.10 per pound. The raisins cost $7 per pound. How many pounds of raisins should be added to 5 pounds of peanuts to make the trail mix? So this box right here is an easy way to set up these weighted average problems when you are using the mixture problems. So what we are mixing together here is the peanuts and the raisins are getting combined to make the mix. So whatever is getting combined is listed on this left-handed side, and mix is always going to be at the bottom because we're always mixing stuff together. Up along the top, we're going to use the units that they give us. So the first one is they're telling us that we're going to be dealing with pounds of peanuts. They also tell us that we're dealing with price, or the money. And this last column for the top is always going to be total. So mix and total are going to be involved in all of these problems, no matter what your other units are. The nice thing about this box is it helps us to keep our information straight. So it's telling us that we have 5 pounds of peanuts. So that goes into our pounds of peanuts. It tells us that the price per pound of peanuts is $2.10, and the price per pound of raisins is 7 cents. It also tells us that the price per pound of our mixture is $5. The question it's asking is how many pounds of raisins. So we're going to use that as our variable. In order to figure out how many pounds of mix we have, we need to be adding up our peanuts and raisins. So we have our peanuts and our raisins being added together. In order to find the total column, this will be the same for every type of problem. You are going to multiply across to find your total. So for the peanuts, we're going to do 5 times $2.10, which gives us $10.50. For the raisins, we don't know how many pounds, but we're multiplying by $7, so that gives us 7x. And for the mix, we don't know the total number of pounds, but we're doing 5 times that sum. In order to finish solving the problem, we're going to do peanuts plus raisins is equal to the mixture. So I have 10.50 plus 7x is equal to 5 times x plus 5. Now we're just dealing with a problem where we have an equation with variables on both sides. I'm going to start by distributing that 5 into the sum. So I have 7x and 5x plus 25. Combining our variables together, I'm going to subtract 5x from both sides, and I end up with 10.50 plus 2x is equal to 25. Subtract 10.50 from both sides, and I end up with 2x is equal to 14.50. Finishing out the problem, we're going to divide that by 2, and I get x is equal to 7.25. In order to figure out what your label is, you're going to want to look at where your x was to start. So x stands for pounds of raisins. So in order to mix it all together, you would be using 5 pounds of peanuts at $2.10 and 7.25 pounds of raisins at $7 to give you your final mixture. These problems could also be dealing with percents. So, for example, recipe A has a dough that is 50% peanut butter. Recipe B has a dough that is 80% peanut butter. How much of each dough should be mixed to make 100 ounces of a dough that is 68% peanut butter? So, again, we need to set it up. That bottom part is always going to stay as mix, and your final column over here is always going to be total. The two things that we're combining this time are recipe A and recipe B, and the measurements or the units that they give us is ounces, so how much dough, and percent. So it tells us that we have recipe A is 50% peanut butter, recipe B is 80% peanut butter, and their mixture has to be 68% peanut butter. Then we have that our total, we want to have 100 ounces. Now, that is all they give us for the ounces, but we can use that value to figure out what we need. So we don't know either quantity, so I'm just going to say that A is X. We don't know how much we have. So in order to figure out how much B is, we're going to take our total mixture and take away however much A is. You could have flip-flopped and said that you want to know B, so make B X, and A be 100 minus X. Either way, one of your values is going to be X, and one of them is going to be the mix minus that X value. It doesn't matter which way you do it. Again, just like the last problem, in order to find the total column, you need to be multiplying. So we have X times 50, which gives us 50X. Then we have 80 times the difference of 100 and X. And on the bottom we have 100 times 68, which gives us 6,800. To set up our equation, the two combined is equal to the last one. So I'm going to end up with 50x plus 80 times 100 minus x is equal to 6,800. Using distributive property, I end up with 50x plus 8,000 minus 80x is equal to 6,800. Since both of our x's are on the same side, we just need to combine our like terms. So I have 50 x's and I am taking away 80 of them. So I have 30x plus 8,000 is equal to 6,800. Subtracting 8,000 from both sides of the equation, I end up with 30x is equal to negative 12,000. Finishing this out, that should be a negative 30x. We're doing 50 minus 80, which gives us a negative 30x. So this should be a negative 30x. And we are dividing both sides by negative 30. And I end up with an answer of x is equal to 40. Now, our question asked us how much of each dough should we be using. So we need to go back and we need to figure out how much of each dough. So we know that we're using 40 ounces of recipe A. That's what we already solved for in the problem. Then we can plug that back in to our answer for B to figure out how much we are using of B. So if I have 40 of A, I take my 100 minus 40, and that ends up with 60 ounces of recipe B. So we figured out both A and B. Go ahead and try this one on your own. So you should have gotten an answer of 12 and a half gallons of solution B. If you have questions about that, please let me know when you get to class. The other thing that we have to deal with is these uniform motion problems. So a simple example of one of these: a runner is traveling 3 miles in 20 minutes, gets tired, and takes another 20 minutes to walk 2 miles. What is the runner's average speed? So we are looking at that formula that we had at the beginning. Distance is equal to rate times time. For these ones, if it is asking you about speed, you are looking for your rate or the rate value in the problem. So our distance here, we have 3 miles and 2 miles, which gives us a distance of 5 miles. And we have 20 minutes and 20 minutes, which gives us 40 total minutes. So in order to solve this problem, we are dividing by 40, which gives us a final answer of reduced fraction is 1 mile in 8 minutes is our rate value. We started with 5 over 40, divide both of those by 5, we end up with 1 mile in 8 minutes. We can also set up these uniform motion problems using the boxes for the ones that are a little bit more complex. So Bob and Ann start biking in opposite directions on a circular trail. The trail is 5 miles long. But Ann is traveling at 12 miles per hour clockwise, and Bob is traveling at 18 miles per hour clockwise. Ann is traveling counterclockwise, and Bob is traveling clockwise. How long will it be until they meet each other? So what we know here is we've got our circular trail. The whole thing is 5 miles around. Ann is going counterclockwise, and Bob is going clockwise, and we're trying to figure out where they're going to meet up with each other. So, in order to use the box here, we have our two people, Ann and Bob, or whatever two things you are combining. And then up top, we are going to be using our formula. Remember, you want to be able to multiply in the middle to get the final answer. So using our distance formula, we have distance is equal to rate times time. Rate and time could be flip-flopped, whichever way you want to put them into the columns. So, we know that Ann is traveling at 12 miles per hour as her rate, and Bob is traveling at 18 miles per hour for his rate. The amount of time is what we are trying to figure out. The one thing that we do know is that they're going to run into each other after the same amount of time. If it takes Ann 2 minutes to get there, it's going to take Bob 2 minutes to get there. That's the time that they run into each other. So the amount of time they're traveling is x for both of them. The distance that they end up traveling is going to be, again, following the pattern, multiplying to equal 12x and 18x. Now, our pattern from before says that we need to add the top two to equal the bottom. So we're actually going to add on that box there. The total distance that they have to travel around this path in order to run into each other is 5 miles. That's how far the whole path is. So one of them covers one portion of the path, the other one covers the other portion of the path, and that total has to equal 5 miles. So our equation then becomes Ann's distance plus Bob's distance is equal to the total of 5 miles. So we have 30x is equal to 5. Solving, we divide both of those by 30, and I end up with x is equal to 1.6 repeating hours, and or 1/6 of an hour. If you wanted to go ahead and convert that into minutes and say that it would take them 10 minutes instead of 1/6 of an hour, that is okay. I would accept all of these answers on the homework and or a test. Go ahead and try this one on your own. So, plugging everything in, we end up with 1.2 hours or an hour and 12 minutes for our final answer. If you have questions about this or anything else from the lesson, please let me know when you get to class.